Okay, so today with what we're going to be looking at, the topic is what we call the graph translation theorem. But before we get to that, I want to go over the worksheet that we had in the previous assignment because it ties into what we're going to be talking about today. So let's look at these four different graphs. So if you notice, we have y equals absolute value of x plus 4. The next problem was y equals absolute value of x, and then plus 4 was on the outside of it. Here we had the absolute value of x, and then the minus 4 was outside of it, and here we have y equals absolute value of x minus 4 inside the absolute value. Now, if they're all four of these graphs, looks like they'd be very similar. Let's look at what the answers look like. So for the first one, y equals absolute value of x plus 4. Notice how we have an x-intercept here, where x is negative 4, and it just so happens to be the vertex of the absolute value function is at negative 4. But when I had y equals absolute value of x and then plus 4 outside of it, the vertex is on the y-axis, but where y is a positive 4. So the next one. Here we had absolute value of x, and the minus 4 is on the outside of it, and the vertex is shifted down to where the y-intercept is at negative 4. And here we have, in this graph, the x minus 4 is inside the absolute value, and the vertex is over here at positive 4. So there are some similarities here. Let's look to see what exactly they are. Then we're going to talk even more about it, where here when you had the plus 4 outside the absolute value or the minus 4 outside the absolute value, it moved our graph up or down. Here's what I mean. If we look at a parent function means it's what all the other graphs are based on. Like here, our parent function is going to be y equals absolute value of x. And what I did is I know this looks like there's a complicated mess here, but we're going to make sense of this in a minute. But what I did is in blue, I have what we call our our parent function for the absolute value function. So y equals absolute value of x is your parent function. All these other graphs are based on that. So when we had y equals absolute value of x, now originally it said plus 4. Now notice I moved it to the other side. There's a reason for that. So y minus 4 was the same as y equals the absolute value of x plus 4. What I did is I just subtracted it from both sides because that's going to tie into the formula that we're going to look at here in a minute. But for this one, if you notice, the vertex was moved from 0, 0, and it was moved up 4 units. So the vertex is now at the point, instead of at 0, 0, it's at the point 0, 4. And we would say that this translation it translated the graph up 4 units. Let's look at the one to the left of it here. Here we have where we had y equals absolute value of x plus 4. Here was your vertex originally, but it's moved to the left 4 units to be at the point negative 4, 0. Let's look at this one. Here originally, this was the graph y equals absolute value of x minus 4. But what I did is I added 4 to both sides. Again, the reason why I did that is to tie into an equation we're going to look at here in a little bit. But when we look at and compare the parent function to our new function, it's been shifted down 4 units. So our vertex is now at the point 0, negative 4. Or over here, let's look at this one. Here we have the absolute value of x minus 4 inside of the inside the absolute value we have x minus 4. And what happened here is our vertex is moving to the right, so it's being translated to the right 4 units. So our vertex is now at the point, it's now at the point 4, 0. Now what's the point of all this? Well, let's compare and contrast our equations with our vertices here. So for example, with this one we had a vertex where x is 4, y is 0. Notice, compare my parent function with my new function, and it's taking x minus our vertex is 4. So it's taking x minus our x value in our vertex, which is 4. Or look at, let's go back up to this one up here, this where we have x plus 4. Our vertex is at negative 4, 0. If I were to take x minus negative 4, it becomes x plus 4. And there's nothing happening to the y, so the y stays the same. Where for this one, let's look at these other two examples where it was shifted up and down. This one, your vertex is at 0, 4. So in other words, nothing's happening with the x, but with the y, it's going up 4 units. And so we have y, we're looking at this equation here. It's y minus the y value, so y minus 4. Down here, the vertex is at 0, negative 4, so it's been shifted down 4 units. And our new equation is y plus 4, or y minus negative 4 would give me y plus 4. So now here's where this all comes together. If you printed out my notes on Moodle, you'd be using this. So again, the topic for today is what we call the graph translation theorem. And what the graph translation theorem states is what's in this box here is that if we have a translation occurring, we represent a translation down here in this box where I boxed in red there. We represent it with the capital T sub h in k. H represents, if you look over to the right here, H represents the horizontal shift. So how the graph is being moved to the right or to the left. If it's to the right, it's going to be a positive shift. If we're shifting it to the left, it's going to be a negative shift. And our K in this translation represents our vertical shift. If we shift it up, it's going to be positive. If we shift it down, it's going to be negative. So that's what the T sub h and k represents. So let's look at this example. It says if I have a translation of T sub negative 2 and 4. So what this represents is that we're going to shift this function, y equals absolute value of x, 2 units to the left and 4 units up. That's what that translation is telling us that we're doing. We're going to shift it 2 units to the left and 4 units up. The reason why I know it's to the left is my first number here is negative, and that represents my horizontal shift. So it's going to go to the left 2 units. My second number refers to how it's going to move up or down. It's positive, so it's going to move up 4 units. Now, to come up with a new equation, that's what this is telling me. We're going to replace x with x minus h, and I'm going to replace y with y minus k. So it's going to be y minus whatever k is, so y minus 4 equals the absolute value of x minus negative 2, which becomes x plus 2. So this would be my new equation. Y minus 4 equals the absolute value of x plus 2. Let's try another one. Here we have a translation of 3, negative 5, meaning it's going to move 3 units to the right and 5 units down. So to figure out what our new equation is going to be, it's going to be a replace again. Going back up here, this is super important. We're going to replace y with y minus k. K is the negative 5. So it's going to be y minus negative 5, which makes that y plus 5. We're going to replace the x with x minus whatever h is, so it's going to be x minus 3. And that would be your new equation. Now, if we took y equals ax squared, that's an equation, that's a general form or apparent function for a parabola. And if we applied the graph translation theorem to a parabola, where if I had a translation, like they say of h and k here, we would have this new equation. It would be y minus whatever k is equals this a, we're going to talk about at a later point, it stays the same. And then we're going to replace x with x minus h. So it'll be x minus h in parentheses squared. Now this equation is very important. It's very unique. There's a special name that we call this. So let's look at the next page. Now you're going to want to pause this video and you're going to want to write down what I have highlighted here at some point, because these are all very important pieces. So let's go through what each of these are. Now what we're going to talk about is an easier way to graph a parabola, because we've done a lot of graphing, especially with absolute value functions. But when we graph, especially with absolute value functions, we were just setting up a table, picking negative 2, negative 1, 0, 1, and 2, using those points and hoping that we'd be able to see the whole absolute value function, but if we didn't, then we'd have to pick more numbers. Well, that can be time consuming. Well, there's a faster way to graph absolute value functions and a faster way to graph parabolas. And that's where we're going to shift our focus now on, is to how to graph parabolas. And in fact, that equation that we were just looking at, like I said here, that is so special, we call that a special name. We call that the, oops, put it in the wrong spot. We call that the vertex form of a parabola. The reason why is one of the first things that we're going to look for when we see something in that form is what is the vertex. The vertex of the parabola, when it's in that form, is going to be the point HK. So because of that, that's why we call an equation in that form, that's why we call it the vertex form of a parabola. Once we know what the vertex is, the next thing we're going to use to graph our parabola is going to be the line of symmetry. Or the axis of symmetry. The line with the equation y equals whatever h is going to be the line of symmetry. Now let's look at some examples to make some sense of this as we're going through it. Let's say if I had the equation y minus 2 equals x plus 4 squared. If I was asked to find the vertex here, the vertex is a point h and k. Now an easy way to find the vertex is just to ask yourself this. It's the x value, or the h part of your vertex, is going to be the opposite of what's ever happening to the x. The opposite of positive 4 is a negative 4, so my vertex is going to be at negative 4. Then to find the y value of your vertex, look to see what's happening to the y here, and take the opposite of that. The opposite of minus 2 is a positive 2. Now you might say, well, why are we taking the opposites here? Why isn't it just 4 and negative 2? Well, remember, if I were to plug these into my vertex form, I should get the same equation. Well, if I take and put this in vertex form, it would be y minus whatever k is. Well, y minus 2 gives me y minus 2. And in parentheses here, I'd have x minus h. Well, x minus negative 4 would make that x plus 4 in parentheses squared. Or if instead, if I had said 4 negative 2, I'd get the wrong equation, because y minus negative 2 would actually be y plus 2. And that's not what we want. And inside of parentheses, instead of x minus 4, we don't want x minus 4 in parentheses, we want x plus 4. So that's why it has to be a negative 4 and a positive 2. And again, an easy way to do that is just take the opposite of what's happening to the x, which is negative 4, and the opposite of what's happening to y, which is a positive 2. So if we were asked to find the line of symmetry is going to be, I'm sorry, I said that wrong back here. My apologies. I don't know why I said y. It should be x equals whatever h is, because this is going to be a vertical line in the form x equals some number. So if vertical lines are always in that form, x equals some number. So in this case here, my line of symmetry would be the line x equals negative 4. So that would be your line of symmetry. The line of symmetry, if you look over here at this diagram, is going to be an imaginary line, so we use a dashed line to represent the line of symmetry. The reason why that's so important is because that's where the parabola is going to be symmetrical over that line. It's going to be reflected over that line. So the next thing we need to look at is whether the graph opens upwards or downwards. And that's going to tell us whether or not there's a maximum or minimum value. Now, remember this A that's up in front of here? That A is important because that A tells us whether the graph is going to open up or down. If A is positive, so it's greater than 0, the graph is going to open up. Well, if the graph opens up, like these two examples over here on the right, that means your vertex, which is down here, is going to be the lowest point on the graph. So it's going to be the minimum value. If A is less than 0, if A is negative, the parabola is going to open downward. And if you have a parabola that opens downward, the vertex of that parabola is going to be the highest point, or the maximum value. Okay, so let's look to see how we would use these things. Because we're going to graph this equation, y minus 5 equals negative 2 times x plus 3 in parentheses squared. So to graph this, I'm going to first figure out what the vertex is. The vertex, remember, is the point h, k. So for this problem, remember, we take the opposite of whatever's happening to the x. The x has plus 3. So the opposite of that is negative 3. So to find the y value, we look over here. We take the opposite of what's happening to the y. Minus 5, so I'm going to take the opposite of that. It's a positive 5. So let's graph our vertex. Our vertex is the point negative 3, positive 5. Then it says write an equation for the axis of symmetry. Remember, the axis of symmetry is equation x equals whatever h is. So the x equals negative 3. That means that I'm going to draw that, I'm going to graph that line, x equals negative 3. That's this imaginary line, so that's why I use a dashed line here, that goes through the point negative 3. Now to sketch a graph of this, we're going to have to come up with some other points that are on the parabola. So we still set up an xy table, but here's the nice thing about it. We don't have to pick random numbers, and in fact, we don't have to pick 5 numbers. We only have to pick 2 numbers. Let's pick 2 numbers either to the right or to the left of that line of symmetry. But we're not going to straddle that line of symmetry, meaning I'm not going to use negative 2 and negative 4. You'll see why in a minute. So let's use negative 2 and negative 1. So we have this equation. I'm going to rewrite this, so I'm going to get the y by itself. So I'm going to write it as negative 2 times x plus 3 in parentheses squared. But I'm going to add 5 to both sides. So now all my process, all my work is on one side of the equal sign. So when I put negative 2 inside of here, I put negative 2, replace x with negative 2. So negative 2 plus 3 is 1. 1 squared is 1. Times that by negative 2 outside the parentheses gives me negative 2. Negative 2 plus 5 is 3. So when x is negative 2, y is going to be 3. Now I'm going to put negative 1 in here for x. Negative 1 plus 3, well, that's 2. 2 squared is 4. Multiply that times negative 2, and I get negative 8. Negative 8 plus 5 gives me negative 3. So now what we're going to do is we're going to graph these 2 points. Negative 2, positive 3. Negative 1, negative 3. That's going to be down here. Now remember I said not to straddle the line of symmetry when you're picking your numbers for this table. Because if I had picked negative 2 and let's say negative 4, well, watch what happens. Because remember, this line of symmetry means that these points are going to reflect over that line. So if I have a point 1 unit to the right of that line, I'm going to put another point 1 unit to the left of that line. If I had picked negative 4, I wouldn't see enough of my parabola to get a big picture of what my graph would look like. That's why you want to pick 2 numbers either to the right of the line or to the left of the line, so then that way it eliminates some of the work, because now all I have to do is come up with my 5th point is to reflect this one that was down here 2 units to the left of the line. Oops. And now we're going to draw our parabola. So it would look something like that. So when you're graphing these, you always want to graph 5 points. So why don't you guys take a minute and, well, let's start this one off together, and then we'll just go through it all together. Why not? So let's look at this one. Again, the vertex is going to be the point h and k. So ask yourself, well, the h value in your vertex, or the x value in your vertex, is whatever's happening to x, you take the opposite of it. Minus 2, the opposite of that would be a positive 2. To find the y value, take the opposite of what's happening to the y. Plus 4, the opposite of that would be a minus 4, so negative 4. So there's your vertex. Let's graph that. 2, negative 4 would be right here. So now it says write an equation for the axis of symmetry. The axis of symmetry is going to be x equals 2. It's always x equals h. So I'm going to graph that with the dashed line. That's also, we didn't do this for the previous one, but it's also good to ask yourself whether the parabola is going to open up or down. We could have been able to tell at the very beginning of this one that it was going to open downwards just because a in front of there is negative 2. Here, a is a positive 3, so that tells me it's going to open upwards. So remember, now we're going to pick some values for x and figure out what y is. We only have to pick 2 numbers, but we pick 2 numbers either to the left or to the right of the line. Let's use 0 and 1. Now again, I'm going to take this equation, I'm going to write it so the y is by itself, so I'm going to subtract 4 from both sides. So it's going to be y equals 3, and then in parentheses, x minus 2 squared, and then minus 4. So now when I go to graph this, I'm going to put 0 in here for x. 0 minus 2 is negative 2. Square that, it makes it a positive 4, times 3 is 12. But 12 minus 4 gives me 8. So when I have x equals 0, y is going to equal 8. Okay, so now I'm going to put 1 in there for x. I'm going to put 1 in there for x. 1 minus 2 is negative 1. Square that, it becomes a positive 1. Times 3 is 3. And 3 minus 4 gives you negative 1. So let's graph those. When x is 1, y is negative 1. That's easy enough. But when x is 0, y is 8. We're just going to estimate where that would be. So here's 5, 6, 7, 8 would be maybe right about there. So now we're going to reflect these points. So I reflect this one over to this point. Reflect this one over to be about here. Whoops. Let's see if I can do that better here. So there's your parabola. So again, when you graph these, you should always end up with 5 points. Now let's tie this all together here. Here we have some graphs where we need to figure out, it says, consider the parabolas at the right. The one that passes through the origin has equation y equals 1/5 x squared. So the blue graph there is y equals 1/5 x squared. The other is its image under a translation. Find an equation for the image. We need to figure out an equation for this green line. Well, the first thing I need to do is figure out what translation is occurring here. Well, I'm translating. My vertex here is going to the right 4 units, and it's going down 2 units. So I'd have a translation here for negative 2. So remember from that equation at the beginning, we replace x with x minus h, and replace y with y minus k. So now in my equation, it's going to be y minus k, so minus negative 2 becomes y plus 2, equals a, so I still have this 1/5. I replace x with x minus h. H is 4, so x minus 4, parentheses squared. So that would be my new equation. Let's try this last one. So with this one, we would translate it to the left 3 units. So it's going to be negative 3. I'm going to move it up 1 unit to be a positive 1. So my new equation, if we look at this one, it's going to be, again, replace y with y minus k, so y minus 1 equals the 1/3. And then x minus negative 3 becomes x plus 3 in parentheses squared. And that would be your answer. So this lesson, there's a lot to it, but in reality, it's really not too difficult if you took good notes. So just remember, there's a couple of key points here. That the graph translation theorem, we always replace x with x minus h, and replace y with y minus k from whatever your translation is. And then you want to make sure you remember these different parts about how to find the vertex, how to find the line of symmetry, how to tell whether a graph opens up or down, and how to use those to graph a parabola. So with that, let's go ahead and work on your assignment. So good luck.